Thank you for coming to the first session of the day. This is part one of a two-part session on building Windows Phone 7 applications with Silverlight. So much content, we couldn't fit it in one session, so it's into two sessions. They do kind of work together, but if you can only make this one and not the second one, that doesn't matter. And if not, you can always catch the second one online later on. So I'm Peter Tor. I'm a program manager on the Windows Phone team at Microsoft. Let's get started, because we only have an hour today. So briefly, just to set the stage a little bit on Windows Phone and what Silverlight does in Windows Phone. It is one of the two main frameworks that you use to build applications, along with XNA. XNA being used typically for gaming, Silverlight being used for everything else. One thing to note is that in-browser Silverlight is not part of Windows Phone 7 at this point in time. So the plugin, if you load IE and you go to a web page that tries to use a Silverlight plugin, that won't work right now. And this session is going to be a very quick look at the things that were added to Silverlight for Windows Phone. So this isn't a Silverlight 101. I assume you already know Silverlight. If not, there's plenty of ways to learn it, and this might still be interesting for you. But this won't be teaching you about XAML and C# and all that kind of stuff. So as I mentioned, this is a two-part session. This first part will cover basic things like how you get input into the phone, how you get output out of the phone, using the web browser and embedding HTML and JavaScript inside your application, and some of the OS integration features that we have. And then part two, which happens not directly after this, but later this afternoon, we'll talk a bit more about structuring an application, a bit about controls and theming, and also some of our cloud services that we support on Windows Phone 7. So that's the kind of the breakdown of the two. And just to be clear, now we're talking about part one, and this afternoon we'll talk about part two. So the goal we had with the application platform for Windows Phone 7 and using Silverlight was that you could seamlessly share the knowledge that you have about Silverlight and the code that you have in Silverlight across multiple projects. So you can write code for the web, and then you can take the majority of that code, run it on the device, and have it working. You can take the skills that you know about XAML, about Blend, about Visual Studio, all the things that you know already, you can take over to the phone without having to relearn a new framework or a new language or a new tool set. And of course, for the C# part of things and the managed code .NET Framework part of things, that also transfers to Xbox if you're writing XNA games, and also to the cloud. If you're writing ASP.NET Web Services or you're in Azure, you can take the same knowledge that you know about managed code and run that across the cloud and the three screens. Now that said, we're not preaching write once, run everywhere. Right? We believe that you can take the same concepts, take the knowledge that you already have, and take a lot of the code that you have and run it in multiple places. But if any of you were here for my overview session yesterday, one of the things we're really focusing on is tailoring the experience for each device, for each screen. So the way that you interact with a PC with a mouse and keyboard is very different than a TV with a remote control or a controller, which is very different from a mobile phone with touch and accelerometer and so on. So the core code can port across the three screens in the cloud. The concepts port everywhere. But we do believe that for the best user experience, you should rewrite at least part of, if not all of, your user interface layer so that it best matches the capabilities and the form factor of the device the user is using. So what happens with Silverlight 3 on Windows Phone? As you may know, Silverlight 4 is out now. The phone is based on Silverlight 3. It does have some features brought in from Silverlight 4, in addition to some other features that are phone-specific. But the base platform is Silverlight 3. And the Silverlight team's done a ton of work on Silverlight 3 to make it really shine on the phone. And the first thing, of course, is performance. On the desktop, of course, Silverlight performs very well, but that's typically because your CPU, your desktop computer has a blazingly fast CPU and a really big GPU and lots of memory, and it can do whatever it wants. So to bring it down onto the phone with less memory, smaller CPU, smaller GPU, etc., a ton of performance work went into Silverlight. That's leveraging the GPU more. That's doing things like off-thread rendering. So even if your UI thread is bogged down doing work, animations that you've kicked off will continue to render on a different thread. It's a ton of work in the platform just to make the performance really, really work well on the phone. So the next thing, of course, is leveraging hardware. And part of that is the GPU, the performance work I just mentioned. Part of it is things like hardware decoding of audio and video. Right? So again, for great performance, great battery life, hardware decode of audio and video. And then using parts of the phone itself, such as the accelerometer or the microphone and other hardware parts of the phone that make sense that weren't in Silverlight 3. So performance, using the hardware of the phone, and then also being just part of Windows Phone operating system. So letting you interact with the Music and Videos hub, or letting you interact with the Pictures hub, and letting you be a real Windows Phone application. And then finally, we want to make it look like the rest of the phone. So the applications that you build in Silverlight on Windows Phone, by default, look like the first-party applications. That's more of my talk later this afternoon, but by default, your apps look like they fit on the platform. Now, of course, you can brand your application or you can theme your application completely differently if you like. So if your corporate color is bright red, you can make your application entirely red and not worry about the kind of black and white stark contrast that we have. But by default, applications look beautiful. So that's a little bit of the introduction about Silverlight for Windows Phone. Let's look at some of the input mechanisms that are specific to the phone that aren't available on the desktop. So the first one, obviously, is text input with the keyboard. And on the desktop PC, you usually have a nice big keyboard. You bang away in the keys. Everything's fine. On Windows Phone, a hardware keyboard is optional. And the device I have today does not have a hardware keyboard. So what we use is we use the soft input panel, or the SIP. And that lets us type in letters and numbers and so on into the device. Now, one kind of tip here is that on the desktop, you might be using key-related events for text input, like key up, key down, key press, etc. We recommend not using them on the phone because the way the SIP works, it doesn't give the events you might expect. And you have issues, for example, if you press the number 2 on the soft keyboard or you press the @ sign, you get the same key because to the SIP it's all the same thing. So it's very hard for you to differentiate exactly what the user is doing using the key-related events. So if anyone's tweeting nuggets, that's a nugget you can tweet. Don't use key up, key down in Windows Phone. They're still there if you need them, but we recommend not using them. Another important thing about text input on the phone is that we support these things called input scopes. And this is something that WPF has. It comes from the tablet PC world. And these are things that change the kind of keyboard that's displayed to the user. So if you're typing in text, you want letters. If you're typing in a number, you want numbers. And so input scopes let you change the default keyboard layout to make it easy for the user to type in text. And it also enables things like autocorrect or spell checking. Because if you're typing in large pieces of text, you probably want autocorrection. But if you're typing in, say, product codes or chat messages with all these convoluted short messages, you probably don't want autocorrect because it'll actually mess up what you're typing in. And then the last thing about text input before we go to a demo is that the password box by default masks out your password with nice little dots, but it does give you the nice 1-second delay. So as you're typing, you get to see the last character you typed before it disappears into a dot. So with that said, let's go and move on to a demo. And we're going to be using the little video camera here, which means I am operating at an angle. So I apologize for any miss. No, thanks. So this appear all right to everybody? This is a high-tech camera running through the PC. So what I have here are a bunch of text boxes. And we'll look at the code in a minute, but I just want to show you the difference between what's the SIP that pops up when I type on the different text boxes. So this first one is a default text box. And you can see I get a SIP. It has a nice QWERTY keyboard. I can switch between numbers mode or letters mode. And of course, I can type a bunch of stuff into it. But it doesn't offer to autocorrect that text for me. It just lets me type in whatever I want. If I go to the next one, this one I've set to be a text mode text box. And you might have seen another little bar popped up, which is what we call the candidate window. And you've also noticed that it's automatically tried to capitalize the first letter of my text box, so put it into caps mode, because it thinks I'm typing normal English sentences. So here I can start typing. Let's type H-E-L-L. And you'll see there's suggestions that come up. So this is the text mode. It does things like capitalizes the first letter of sentences. It offers you spell checking corrections, and it lets you do things like pick words to autocomplete. Now, I apologize, you can't really read the text necessarily, but it's offering auto-completion just like you'd expect in a standard text input. The next one is a number field. And now you can see by default it's switched to numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9. I can still go to letters if I want, but it defaulted to numbers. So a text field that's supposed to take numbers can default to this input scope, and the user gets numbers without having to press the toggle between numbers and letters. The next one is a telephone number, and this one's even bigger with the numbers, so it doesn't even let you type in letters. If you're clearly typing in a phone number, or say you have a calculator and you're only typing in numbers and nothing else, this one lets you type in numbers nice and easily. Next is email address or email name or address. This one is mostly the same as the standard keyboard. It doesn't do autocorrections, etc., because of course most email addresses aren't real words. But you'll notice, maybe you won't, but there's an @ sign down here and a .com sign down here. So I can type in gggg@hhhhhh.com or .edu, .net, etc. So again, it's a keyboard optimized for doing a specific type of input. Search is almost exactly the same as the normal input, except this key down the bottom right is a white kind of go arrow for search rather than an enter arrow. And the password box, this is where you might have trouble seeing, but if I type in G, you see it does the letter before it converts it into a dot. So that's a quick demo of some of the input scopes that we have. Let's look at the code for that one. Actually, there's no code. This is all XAML. It's pretty basic. Let's go down to textpage.xaml. And you can see all I really have is my design surface on the left, what you just saw on the device. And I have a bunch of text boxes. The first one has an input scope of text. The next one has an input scope of number, telephone number, and so on and so forth. Another thing, if people are tweeting nuggets, I always write phone number here and then my app crashes. So it's telephone number, not phone number. And doing this in XAML is very easy. You can just type input scope equals string. If you're doing it through code, it's a little bit more complicated because input scope is actually a collection of input scopes for compatibility with the desktop, although Windows Phone only supports one input scope at a time. So that's a quick look at the software keyboard and input scope. Now, another key type of input on the phone is touch, right? And there are 3 and 4, actually, if you include X and A, types of touch on the phone. The first is mouse events. So as you move your finger around, we simulate mouse events like mouse up, mouse down, mouse button up, mouse left button down, mouse move, etc. And that's so that if you have old code, it continues to work on the phone. We also support manipulation events, so things like pan, flick, pinch, zoom, etc. And there is a touch.frameReported event, which gives you raw touch input, so 4 or more touch points doing whatever you want on the screen. And then if you want, you can use the XNA touch panel, which is another way of getting the raw touch input on the device and also filtering through to get specific gestures. And of course, our standard controls just work. So if you have a button, it still fires the click event when you tap on it. If you have a scroll viewer, it pans or it flicks when you do this on it. And the text box handles things like cursor placement. So if you tap and hold, you can move the cursor to get a nice, precise cursor placement. So all the things that you'd expect to happen are built in. And let's go again to a demo and then show the code again. So let's go back to my video. So here we have a nice green dot in the middle of the screen. Green is my accent color. So if I was a blue, I had my accent color to blue, this would be blue. And you can see as I move my finger around, it follows my finger. And as I pinch and zoom, it gets bigger and smaller. Right, so standard events for moving things around and for making them bigger and smaller. So very standard touch interaction, and I'll show you how easy it is with code. Back to Visual Studio, and let's look at manipulation. So as you can see, the circle here is blue because Visual Studio defaults to the blue theme. But all I have here is really a canvas that's as big as the screen, 480 by 800. It has an event handler for manipulation delta, which we'll look at in a second. And then I have an ellipse that is 100 by 100 stuck in the middle of the screen. And it has a composite transform on it so that I can do things like move it around and make it bigger and smaller. So that's all there is for the XAML on this one. And let's look at the code. It's actually very, very simple. It's all in this one screen. So we have our manipulation delta event. There's actually 3 events that happen with manipulation. There's manipulation started, which is when you put your finger down. Manipulation delta, as you move them around or pinch and stretch, etc. And there's manipulation completed when you finish. And when you finish with manipulation completed, it'll also tell you if there was an inertial type flick versus a pan and so on. But for this demo, all we need is delta. We don't care about start and finish. So first of all, we check, is the original source of this manipulation the ellipse? Because if I'm just moving my finger around on the background, I don't want to move the ellipse. I only want to move it if I actually touch it. And if the source is the ellipse, then I'm simply going to use that composite transform that was defined in the XAML and move it around based on the translation that came from the manipulation event. So it gives you translation and scale in terms of point. So I'm going to move it around based on X and Y translation. And I'm going to scale that based on the scale factor, which is the size of the object right now. Because if you don't scale it, then as the object gets bigger and you move, it moves slower. Probably something to do with Newton's law, but that's the way that manipulation works. The transforms work in Silverlight. So that's following my finger around. The pinch and stretch thing is very easy as well. So first of all, we check, is my manipulation delta non-zero? Because if you're just using one finger to move things around, the delta will be, the scale will be 0, and you don't want to have a render transform of scale 0 because then it will disappear into nothing. So we make sure that my scale is not 0, and if it's not, we take the average of X and Y. So if you do this one, you get a Y delta manipulation. If you do this, you get an X delta manipulation, and of course you can do various things in between. But this is just a circle that we want to take the average, so we add them both together and divide by 2. And then we simply scale take the scale transform on that ellipse and multiply it by the ratio that we got, the average ratio, making sure that we don't go below 1, so I don't disappear into nothing. So there you are. It's really 4 or 5 lines of code to do making a thing follow your finger and pinching and stretching something to go in and out. So very, very simple to do gestures in Silverlight on Windows Phone. All the demos here are very, very simple. There won't be like reams and reams of really complicated code here. It's all very simple. So the next thing we're going to look at is accelerometer, another form of input unique to the phone. And this obviously measures forces on the phone. Z-axis, I can say Z here and don't have to say Z. The Z-axis is kind of right through the middle of the screen. The X is, of course, across the screen like this, and Y is up and down the screen like this. The only really tricky thing to remember about the accelerometer is that it fires events on a non-UI thread. So when the accelerometer gives you a change, you need to dispatch to the UI thread. I guess the other tricky thing is Y is really backwards. So Y going up the screen is positive, whereas typically you think of going down the screen as positive. So that's the other tricky thing about accelerometer is if you wonder why your things are going the wrong way, it's because Y is inverted. And let's look at a demo. Let's go back to the screen, and we can see already that this screen is this surface is not particularly flat. But I have my standard, again, the same green ball moving around the device just by tilting like this. So a very, very standard basic accelerometer demo. Let's look at the code at the accelerometer page. Now, this one is a little bit more complicated. The XAML is exactly the same. I have a canvas, but of course I don't need a manipulation handler because there's no manipulation handling going on. And I have an ellipse in the middle with a composite transform. If I look at the code for this, there's a little bit more code here, but it's still not very complicated, mostly to do with boundary conditions, making sure I don't fall off the edge of the device and keep going forever. So I create an accelerometer and handle the reading changed event, which is what fires very, very often. I can't remember the exact frequency of the accelerometer, but it fires a lot. Then I'm going to create a dispatcher timer, basically firing once every frame, that is going to update the ball. So I mentioned in the previous slide that the accelerometer events fire on the non-UI thread, so you need to dispatch to the UI thread. I'm taking a slightly different approach here, which is essentially I'm going to let the accelerometer keep going on one side of one thread, updating some values, and I'm going to use a dispatcher timer to pick up the values every frame. So various ways that you can handle the same problem of accelerometer happening on the background and your UI happening on the main thread. I chose this one because it just gives me an easy 30 frames per second way of doing this. So just a little bit of housekeeping here. I'm using onNavigated to and onNavigated from, the two events that happen when a page gets navigated to and from, to start and stop the accelerometer and the timer. And this is something that I will go into more detail in part 2 around the life cycle of an application and how you behave well on the phone. But essentially, if I'm on the page with the accelerometer and then I switch to a new page, I don't really need to keep the accelerometer running using battery, so I can turn it off. So that's what happens when I navigate from. I stop the accelerometer and I stop the dispatcher timer. And if I navigate back to the page, I turn them on. So that's just a little bit of housekeeping to stop your code from running even if the page is not the one that's currently in the foreground. Now, let's look at the accelerometer reading change. This is very, very easy. As I said, the accelerometer reading change happens on a background thread, and all I'm doing is updating these two values, delta x and delta y, which are how much the ball should move the next time I draw a frame. So nothing very exciting happening here. There's also a delta z, which is, of course, the change in the z accelerometer reading. I'm not using it here. I was going to try and use it to shake the device and make the ball get bigger and smaller, but it ended up being too much code and looked weird. So that leaves move ball, which is the method that gets called every time that dispatcher timer ticks. So 30 times a second, we call this move ball. And again, it's some simple math around the composite transform that's applied to that ball. I'm going to translate x or y between the maximum left and right, so right and bottom edges of the screen, and the minimum left and top edges of the screen, and delta what the accelerometer told me. So as long as I'm within the bounds of the screen, the ball will move in the direction that I'm pointing. And then if I am off the edge of the screen, I'll set the delta x or delta y back to 0. Otherwise, it takes a long time to kind of reverse the flow. So these lines here are really just to make sure that once you hit the boundary, it's easy to start going away again. So a little bit more code and manipulation, but again, very, very easy to do this because of the way that Silverlight works with transforms and so on. You get these readings from the accelerometer, you just plug them into the render transform on the object, and it moves around the screen. So very, very simple to use both the gestures and the accelerometer to move stuff around the screen. So the next one is microphone input. And this is something that we actually get from XNA. Silverlight does not have a microphone API. Silverlight 4 has a webcam API, but Silverlight 3 does not. So for the Windows Phone, we actually use the XNA API to get microphone input. And this is essentially the raw PCM data coming in out of the microphone. There's two ways to do it. There's a polling mechanism to basically, whenever you want, ask the microphone for some data. You get the data and you do stuff with it. Or there's an event-based mechanism where it will call, fire an event every so often, and you can read the data off it. And two things to make a note of here. First one, again, if you're tweeting nuggets, you can tweet these. First one is that make sure that the microphone state is actually started. If you try and get data from a non-started microphone, it won't work. And the other one is that you need to call the XNA framework dispatcher on a regular interval. So XNA, as you may know, is more of a game loop type framework. So basically, it calls you to update and draw yourself 30 times a second, versus Silverlight, which is more of an event-based system. If there's nothing to do, Silverlight won't call you, and then when an event fires, Silverlight will call you. But XNA's internals rely on this kind of constant loop going. So if you're using XNA APIs from Silverlight, you need to call the framework dispatcher every so often. They recommend once per frame, so say, for example, every 33 milliseconds. Let's have a look at a demo of this. And this is a demo I coded this morning before this talk. I wasn't sure if I was going to be able to do it, but let's look. Switch over to this. So what I'm doing here is I'm taking the raw audio and basically writing it into a writable bitmap and putting that bitmap on the screen. So 10 times a second, I'm getting audio from the microphone, and I'm just blasting the bits into a writable bitmap. So it's not very sexy, but you can see if I'm silent for a minute and I make some noise, it reacts. So like very, very poor man's visualization app. Not a very pretty visualization app, but a visualization app nonetheless. And we'll look at the code for that one too. Let's go back to Visual Studio, to the audio page, which is, where's my audio page? Here it is. Very, very simple XAML. All I have on here is an image that fills the entire screen, so nothing particularly interesting there. The code is, of course, the interesting bit. And this is, again, not very complicated. There's a bit more stuff to work around because I'm taking raw byte values from the microphone and then munging them into a color and then putting them in a bitmap. But the code is still relatively simple. Excuse me. I have a microphone, which represents, obviously, the microphone. A writable bitmap, which is what I'm going to write the bytes into that get put onto the screen. I have a dispatcher timer, which is going to let me do the framework dispatching that I talked about XNA, and then a sample size, which is how many bytes I'm getting per sample from the microphone. So simple initialization, I get the default microphone. You can have more than one microphone, but you get the default one in this case. I set the buffer duration to 100 milliseconds, so basically get it 10 times a second. And I figure out what the sample size is for that, which turns out to be 3,200 bytes, but that's kind of beside the point. I create a writable bitmap of 100 by 100. That's the thing that's going to fill the screen. And then I have a dispatcher timer, which is going to call that framework dispatcher.update method once every 33 milliseconds, so every 30 times a second. And that's going to make sure that it can keep pumping the microphone data. Just as with the accelerometer, I use onNavigated_from and onNavigated_to to start and stop these services. So if I was on this page using the microphone, then I navigated to another page, I will stop the microphone and I'll stop listening to the events. And then if I come back again, I will reinitialize for those events and start listening again. And then this is the interesting bit, which is the mic buffer ready event handler. So remember I said if the microphone isn't started, don't do anything. This is the line there. So basically I make sure that the mic has started successfully. Then I get the data from the microphone using the getData method. And that just gets the raw bytes out of the microphone buffer into my buffer. And then I just have a very simple loop across all the rows and across all the columns. I'm going to pull the byte out of the data, out of the microphone data, and then I'm going to kind of coerce that into a grayscale color. I could try and do a color, but that requires a bit more math that I didn't want to do. So I simply convert it into a grayscale color and then whack that into the writable bitmap. And in this particular example, because the sample size is smaller than the image size, the data will repeat a couple of times inside the image. So that gets me my audio data into a visual form. And then, of course, I dispatch that off onto the UI thread to draw. So that's all it took to do the very simple visualization. So you can imagine if you made this data ready event a bit cleverer, you could actually have a very pretty visualization. So the next one is output. So all of that was just input. So touch, text, accelerometer, and microphone. Let's talk about output now. Media, of course, is a big part of Silverlight. And we, of course, support media inside Silverlight for Windows Phone. We do support hardware decoding of media. So great performance, good battery life with the media decode. We support media stream source as well. So if you have your own custom kind of envelope format for media, or you're doing smooth streaming, for example, that's supported on Windows Phone. And it supports PlayRead DRM as well. Now, there are a couple of limitations with media because it is a small device and we are using the hardware decode. One of those is that you can only have one media element active at once. So you can't have 5 videos on the screen all kind of animating around. And the other thing is there's no video brush, because the way video brush works is it takes the frame buffer, copies it into the video brush, and then you paint something else with that. Because we're rendering directly through the hardware, to try to get that data back out into a video brush to put somewhere else is too complicated. So because we're using the hardware decode, you get great performance and great battery life, but there are a couple of limitations here. Now, what you can do, I said there's only one media element, that's for both audio and video. And so for Silverlight Windows Phone, you should not use the media element for doing simple sound effects. Right? Media element is for video playback and for music playback, so long-form audio. If you're playing small sound effects or something that isn't really music, then you would use the XNA sound effect API. So just like I used the microphone API from a Silverlight app, you can use the XNA sound effect library from the Silverlight app, and it lets you play multiple sounds, and you can dork around with the raw audio buffers and so on and so forth. So that's how you do multiple audio files at once on Windows Phone. So let's take a look at the media on the phone. Whoops, it was already running. Here I have my media page, where I put in landscape. And you can see I've got a couple of app bar buttons here. I've got play and rotate. So hit play, the video is going to play. And this is just a video I took at Teched, Australia, of the beach. So it was sunny there. And I mentioned there were some limitations about video being, you can only have one of them and there's no video brush. But it is still a proper Silverlight surface. So you can do everything you can do with a Silverlight surface. So here I'm doing some plane projections on it while the video is playing. So limited in the sense you can only have one, but it's still a true Silverlight media element. You can do plane transforms, you can do projections, you can do a bunch of other things on it. So it's still good old Silverlight goodness. Let's look at the code for that, which is really quite simple. Media, obviously the media page has the storyboard animation I just had, which is basically just animating a projection. It has a media element, of course, set to the video file that I took on the Gold Coast with the plane projection so that I can do the cool rotation. And I have some app bar buttons set up, one for play and one for rotate. So that's the XAML for this. The code is relatively simple. On the media opened event, I enable those two buttons because, of course, if you try and play media before it's opened, bad things happen. So I disable the two buttons, and then when the media is opened, I enable them. If the play button is clicked, it's basically a play-pause toggle. So if the media was playing, I pause it and make the button say play. And if the media was paused, I play it and make the button say pause. So that's just a bit of UI stuff there. And then for rotate begin, I just begin the storyboard. So again, very, very simple code to have video running in your application and to do some cool transforms on it. Another form of output we have is vibration. Very, very simple. You can vibrate the phone for a set time. You give it a number of a time span to vibrate for. It's useful for games, of course, if you want to give kind of haptic feedback for games. And useful for error conditions as well. If the user is doing something on the phone that isn't supported or isn't valid right now, you might vibrate the phone. And the API is very, very simple. This one line of code will vibrate the phone for 1/5 of a second. I don't have a demo for this because obviously you can't really see it vibrate on the screen, plus it's only one line of code. What I will say about vibration, though, is that it's not used a great deal in the first-party experiences. So it's not something that we've really established a pattern for using on the phone. So don't go crazy vibrating all the time. Obviously, if you're a game, it makes sense to vibrate, that's fine. But don't vibrate on every button press or anything like that, because it's not something that the phone really does. So that was output. So input was text, touch, accelerometer, and audio. Output was media and vibration. And of course, you can do play audio as well. I cut down the audio on this one, but there's audio as well. You can do anything Silverlight-y, like put rectangles and buttons and images on the screen and transforms and so on. So all standard Silverlight output is there. And the next one is the web browser control. So the web browser control is something that you may recognize from Silverlight 4. We've actually done a bit better than Silverlight 4, and I'll talk about that in a second. But the web browser control displays content either from the network or local content that you've stored as part of your application. It supports the standard web browser type gestures, so you can pinch and zoom to zoom in and zoom out. You can double tap to pan in, etc., to zoom in, etc. It supports transforms and projections, and this is where it's different from Silverlight 4 version in that it is a true Silverlight element. So I can take a web browser control and I can rotate it if I want to. I can have multiple of them on the screen. So unlike the media element, you can have more than one web browser, and they can all be animating around the screen. You can, of course, interact with the controls inside the web browser. You can enter text into the web browser. You can click form controls in the web browser, etc. And the web browser control, the content inside it, can interact with your application and vice versa. So if you're hosting some content inside the web browser control, and the application wants to manipulate the content, it can do that through an API that I will show you. It can actually invoke script inside the web browser control to do stuff. And similarly, if the web browser wants to interact with the hosting application, it can basically raise an event on the application that will tell it to go do stuff. So we've seen on various platforms that a lot of applications are actually built as mostly in HTML and an HTML control with a thin Chrome around it to make it into a marketplace type application. So you can do that on Windows Phone as well. You can have the majority of your content in HTML, if that's what you're more comfortable with, put it inside a Silverlight application kind of wrapper, and still have it do things like have application bar buttons and have a system tray and do cool phony type things by letting the content inside your web browser talk to your Silverlight content and vice versa. And the last 2 points here are that the control is optimized for privacy. By default, script is turned off, so you can run script inside these web pages, and as I mentioned, you can talk back and forth between your Silverlight and your script, but it's turned off by default. So if you accidentally navigate to a page that does something stupid, bad things won't happen, unless, of course, you opt in to running script. And then the cookies and the cache that the application uses are isolated. So there's a system-wide cache used by the browser. If you go start and run the IE browser, that has its own system-wide cache. But each application has its own separate store for cache and cookies. So your application can't have its cookies or data stolen by another malicious application. They're completely segregated. So calling between Silverlight and JavaScript, anyone that knew me 10 years ago, I never would have said JavaScript. I would have said JScript. I used to be the JScript PM at Microsoft, and back then it was all JScript. But now I give up and I just call it JavaScript. So Silverlight can use this method called invoke script to invoke a script function. So here I'm going to invoke the JS function and pass a couple of arguments. And then JavaScript defines that function. It can do stuff and it can return a result. So calling JSFunc from Silverlight invokes JSFunc in the browser, and of course it can return something back to Silverlight. Excuse me. And going the other way, rather than a direct method call, we use an event-based system. So in JavaScript, I have a param called hello world, and then I do window.external.notify. So window.external is this object that you can slap into the IE rendering engine to represent the host context of the control. Right? In this case, window.external represents your Silverlight application. So you call the notify method, which ends up becoming an event on the managed side. And so in my notify event handler, I simply get the value out of the event args and do something with it. So that's the way that you call from Silverlight to script, and then script back to Silverlight. So let's have a demo of that. So here we have, at the top, in the black portion, this is the Silverlight portion of the app. It has a text box that says this text will change. No points for guessing what happens to that text. And a button that says click me. And then below that, the white section is the web browser. And I have the same thing. I have some text that says this text will change. And I have a button defined in HTML. So if I click this button here, the top button, the Silverlight button, you'll notice the text in the web browser changes. So I click this, And now inside the web browser control, the text says hello from Silverlight. And if I click the button inside HTML, the text at the top now changes to hello from JavaScript. So this is just demonstrating a button in Silverlight modifying the HTML inside the control, and then a button inside the HTML modifying the Silverlight content. So let's take a look at the code for that one. This is our second last demo. So here we have a very basic page. We have a text block at the top, which is this text will change. That's the text that's going to change. I have a button, click me, that's going to do something when I click on it. And I have a web browser. And you'll notice I've set is script enabled to true, because as I mentioned, by default, script will be disabled. So if you forget to do this and you wonder why your app doesn't work, it's because script isn't actually running inside the control. So that's another kind of nugget for you, is defaults to false. If you want to run script, set it to true. Script notify is that event that gets fired when JavaScript calls notify. This is the event that gets fired on the web browser, so I'm handling that. And I'm handling the loaded event too, because the web browser, until it's loaded into the visual tree, doesn't like being poked. So we can't poke it until it's loaded in the visual tree. And if we look at the code here, it's, again, relatively simple. All these code samples are very, very simple. Button click, what happens when I click the Silverlight button is, just as in the slide, I call the invoke script method on the web browser control. I'm calling a JavaScript function, there I said JavaScript. I'm calling a JavaScript function called callScript, and I'm passing in the text, hello from Silverlight. And when I get the notify event from the script inside the page, I'm simply sending that message box, that message text box text to be the value that came from the script. And then when the web browser is loaded into the visual tree, it's now set to poke it. And so I just navigate to this constant string defined in my app, because it's easier than trying to load a resource and all that kind of stuff. So if there's any kind of HTML5 gurus out there, they might be upset with what I've done here. Maybe I didn't use the right CSS or something. But very, very simple. I have a script function called callScript, and that's the thing that Silverlight calls. And all it does is set document.all.message.innerText to arg1. That's probably where the purists would not like what I did. And then I have the call Silverlight function, which is a function that's called when I click the button inside the HTML, which calls the notify method hello from JavaScript, and that fires the event in the Silverlight code. And then I simply have a heading with the message, this will change, and a button with the on-click handler set to call the Silverlight code. So this is the method that Silverlight calls to change the text inside HTML. And this is the method that HTML calls to change the text inside Silverlight. Now the last section we have is on operating system integration. And so there's various ways you can integrate with the operating system in Windows Phone. First is integration with the Music and Videos Hub. So people seen Music and Videos Hub? No? Wow, down at the expo downstairs, there are some Windows Phone 7 devices flying around. You should go take a look. Let me just show you now, actually. If I go home, Music and Videos. So Zune is the playback client for Windows Phone. Zune is also the PC software that you use to sync between the phone and the PC. In the US, we have a great marketplace for Zune, etc. We're not announcing anything yet, so I can't tell you anything about the Zune service. But Zune will be the client that you use on the device for playing music and videos. And you can see here, if anyone's seen a Zune HD or a previous Zune device, it's a very similar UI. I have my music, videos, podcasts, etc. Whoops, and I clicked a button. That's the radio. It's one of these panoramas, so I can scroll across. I just hit the radio button, so it was going to try and play some radio for me. Here are some recent things I've played. So I've played an album by the Pet Shop Boys. I've played some videos that I took. Here's the video of the beach. Here's some content that I recently synced funnily enough, more Pet Shop Boys. My background image is Pet Shop Boys as well, so you can guess who I listen to a lot. And that's all I have on this phone. All I have on this phone is some Pet Shop Boys. And so this is the Music and Videos Hub, and what you can do with a Silverlight application is you can modify this now playing tile. So if you have a media-based application that's playing videos or music from your own service or your own application, you can actually modify what this says so that if the user is in your app and they start playing some media, then they hit start and they hit zoom. What they see here is whatever you said should be there. So your own picture and your own text. Similarly, this history tab here can show stuff that your application has played. So again, if you're in your application, you've played some music or you've played some videos, you can add them to this history list here so the user can click on an icon and immediately be back inside your application. So there's ways that your app can integrate with the first-party Music and Videos Hub on the device. Now the next way you can integrate is with what we call a Photos Extra. And so just as there's a Music and Videos Hub, there's a Pictures Hub on the phone, and that's where you look at all your pictures, the pictures you took taken with this camera, the pictures that you synced from your PC, the pictures that you have on the web, the pictures that your friends post on Facebook, all this kind of good stuff. And from within there, if you're viewing a picture inside the Pictures Hub, you can actually register your application as a Photos Extra. So let's say you have a photo editing application that lets you colorize images or lets you put funny faces on people or anything that works with images. You can actually register so that right from within the Photos experience, the user can launch your application. So again, you're integrated with the Pictures experience. The user doesn't have to think, where did I put that application that puts funny faces on people? Go find it in the application list, launch it, then say pick photo, then go back to your Photos library, then pick a photo, then come back, then do what they were doing with it. Instead, they know they want to work with photos, so they go to the Photos Hub, they pick the photo, they tap on it, and they say launch with photo editing app. Right, so it's part of our integrated experiences that your application can be part of the Music and Videos Hub and the Photos Extras Hub. And then the last one, which I have a demo for, is launchers and choosers. And this is how you interact with resources on the device, such as phone numbers, email addresses, launching an SMS message or an email message, taking a picture with the camera, etc. So let's do a demo of that. Whoops, I do not have a PM meeting right now. Let's run the application. Let's go camera. And what I'm going to do now is see there's a button here that says take picture. I'm going to click that, and it's going to launch the first-party camera experience. So I'm going to take a picture of all of you. Don't worry, it's not going to go anywhere. So take a picture. Everyone smile. Oh, and an accept button comes up, but it disappears so quickly I have to take another one. So I hit the accept button, and now here I am in my application, and there's the image I just took. And of course, again, it's Silverlight, so I can do stuff like spin it round, do transforms on it, do stupid things with it. So that's how I can take an image with the camera and have it in my application, and it's just like any other image inside Silverlight. And then last piece of code we'll look at, let's look at, where is it? photochooser.xaml. So very simple here. I have my animation to make the photo spin, just to show that it's Silverlight. I have a couple of buttons, one to take the picture, one to spin. And then I have an image with a render transform on it. So nothing fantastic inside the XAML. If we go to the code, you'll note I create this thing called a camera capture task. This is the thing that lets me launch the camera, get back a picture. I hook up the completed event, so when the photo is finished being taken, this event will fire. I can do stuff with it. And here is the event handler. If the task result was not okay, so say the user just hit the back key because they didn't want to take a picture, I'll just return and do nothing. Otherwise, I will create a new bitmap image. I will set the source to be the chosen photo, which is just a stream. So you can take that stream and you can write it to disk if you want. Excuse me. Or you can take that stream and you could upload it to a web server. Or in this case, I'm just going to take that stream, slap it in a bitmap, and make that the source of my picture inside my XAML. And then, of course, my two button handlers, one calls camera.show, launches the camera task. The other one calls rotate image begin to do the rotation. So again, very, very simple code here. Obviously, if you wanted to save the image to disk, it's a little bit more code. You create an I/O stream and you write it to isolated storage. But just to get the image on the screen, very, very simple. So that was the last of the sections and the demos, etc. There's a ton of related content on Windows Phone here at TechEd New Zealand. Some of these sessions have already completed, but I'm told they will be online at some stage. Others have yet to be done, so please go ahead and look at those. In particular, part 2 of this one is later this afternoon, where I'll talk more about application structure, controls and theming, and push and location services. Session evaluations are very, very important. Please fill them out. They help us make the conference better for you. So when you pay your hard-earned cash to come here, you get quality content. I can hear everybody getting ready to leave now. And that's it. As you know by now, we don't do questions here because we have a quick turnover. So I'll be outside if you want to ask me questions when I've closed down here. So thank you all for coming.